No, I think that's cool. Yeah, no, me too. I mean, I learned from everything. Showing up at 9:04, doing exactly 9 miles, you know, fine.
Welcome to Austin on Rails. How many of you, is this your first time coming to Austin on Rails? Awesome! So many new people, that's amazing. We're very happy to have you here. So my name is Ceci, I'm one of the organizers. Shneem's over there, Richard Schneeman, we call him Schneems. He's also another organizer. So if you have any questions, feedback, whatever, feel free to reach out to us. So how does it work for those of you who are new? So usually from 6:30 to 7 we have just social happy time, which we've already accomplished. Yay. And then around 7 p.m. We have our first talk. And then after that we have a quick break. We hear from our amazing sponsors for the month. So today I would like to say thank you to Zach over there from Austin Fraser for sponsoring pizza. And then the lovely ladies from Intercis also sponsored beer. So we like beer. So at the break you'll be hearing from them. And then you can also feel free to come and talk to them. They are hiring, so they want to hear from you. And then at 8 p.m. we're going to reconvene. We're going to do our second talk. And then after that talk, we typically do sort of like this optional, what we call socialization practice over at the Ginger Man. It's just grabbing beers and talking about what we learned or didn't. Hopefully you did learn something today. So with that said, let's go ahead and get started on our first talk. Dun, 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 dun,
Hi everybody, I'm Tim Scott. I'm an independent consultant working on Ruby on Rails, and I've been spending a lot of time over the past about a year and a half or so working with GraphQL. First with in the Node.js world as a backend for a React Native app, and more recently I've been working on building an MVP for a startup called Maker. We're building a online printing portal for that's tailored for like Etsy artists and designers. And we're just getting close to launch, and I've learned a ton about GraphQL, and especially lately how to do it in the Ruby and Rails world. And I just wanted to share that with you. First, just to get a kind of a gauge on the audience, who has actually built something or gotten their hands dirty with GraphQL? A few people to keep me honest, okay. Who would say that they kind of know what it is and pretty familiar with what GraphQL is about? Okay. So I'm going to start with just kind of describing what GraphQL is, a little bit about its history, a little bit about why we even care about it, and then we're going to build a GraphQL server. Now, given time, I'm probably going to be doing a lot more sort of copy-paste from my reference app than actually hand coding, but I think you'll get the idea, and we actually will build something from scratch. So what is GraphQL? GraphQL is a query language for your API and a server-side runtime using a type system you define. This is pretty much verbatim from the GraphQL docs. The second point, really, it's more of a spec for server-side runtime, and it's been implemented in many languages, probably most languages by now. There's another part to the server-side runtime, which is there's a schema definition language as well that can be used instead of your native language, like Ruby in this case, to actually define your type system. And it was created by Facebook. Let's talk just a little bit about the origins at Facebook. So around 2011, Facebook kind of made a strong commitment to mobile. They realized that more and more of their users were going to be wanting to look at their status, share their status on their phone. And so they started out betting on web-based approach to mobile. And pretty soon, like a lot of other companies, they realized that there's a lot of power in native, and they were going to need to step up to that. And so while they probably had some data APIs, most of their web stuff was server-rendered HTML, so they had to start building out APIs, which they did, as anyone would at that period in time, and using REST as their primary API architecture. And pretty soon, they discovered that there was some pain involved there. And so, a company of that size can get pretty creative and open the lens pretty wide when they're looking to solve pains. And so they created GraphQL. So let's look a little bit about some of the things that they've reported that were the pains that they found with REST in their world. They found that to populate a lot of views required multiple round trips to the server. You fetch this bit and that bit and several different bits from different different routes. And that was slow, and if you're doing multiple calls per view, it increases the chance that one of them is going to drop and your page is going to be broken. Another big problem is, REST. There are ways to kind of have your RESTful call to a resource kind of determine the shape of your data or the projection of your data, but for the most part, it's not built for that. So if you have, a resource to get a list of widgets or whatever, and then another resource to get the whole widget to edit, the shapes of the data are pretty fixed, right? And so if you're populating a drop-down list, maybe you only need 2 fields versus a table you need more. And so they found that a lot of calls to get RESTful resources were returning overloaded, a lot more data than you need at that time. And of course that increases over time because one client or one view needs a new field, and so it just gets added, and it's just a lot of data unnecessarily coming down the pipe. And kind of for the same reason, the API gets ever larger because this or that client or view needs a new special projection of a certain piece of data. They also found that a client is always somewhat coupled to the server, but they found that with REST there was a high level of coupling. The front-end engineers really had to know and consult the specifications on the server. And also, if a front-end engineer needs a new field on a view or something, and the company has separate teams, then they have to make a request to this team to add this to the server, and it just slows things down. And everyone knows about, /API/v1/v2, etc. Versioning in REST is a big headache. So they created GraphQL. First, the way they describe it, the folks that talk about it at Facebook, is it required sort of a mind shift again from resources to a graph. And just to be clear, this is not like the Graph API for their social stuff. And it's not a graph database. Graph just means a hierarchical structure of data. And it's declarative. So rather than defining operations or routes to resources, they're actually declaring statically the structure of the data in a GraphQL. And sort of the top level citizens in the GraphQL world are types, queries, and mutations. And we'll get into that some more, but it means pretty much what you think it does. So instead of using HTTP and all the semantics of HTTP and verbs and content types and so forth, it kind of might give you some bad deja vu to the days of soap. I don't know if any of you dealt with that, but trust me, it's not like soap. Okay, so let's start with just looking at a bit of GraphQL code. So what you're looking at here is the schema definition language. We're going to do this same thing using the Ruby gem DSL. But let's just break this down a little bit. So type is user, and then the bits in blue here are called fields. And actually, I'll work from the bottom up. So interest then is a list. That's the GraphQL parlance, is a list of strings. Occupation is a string. Name is a string, and ID is an ID. So a couple things you'll notice is the bang at the end of string. What that says is essentially it's a promise that it'll never be null. So if you're a client-side developer, you can expect that will always be populated. Same with ID. There are only 5 scalar types in GraphQL: string, float, int, boolean, and ID. Now you can define your own scalar types like dates or things like that, but that's up to you. So what's an ID? An ID is essentially, it's serialized as a string. So if you're consuming it on your client, it's going to take the form of a string. But the ID is essentially a guarantee that you will never get 2 of them with the same value. So it's a guarantee of uniqueness, so that if you're building, say, a React app and using something as a key, you're always safe using ID. Okay, so this is a query. Now we're into the query language part of GraphQL. So what we're looking at here is the outer brackets define a query. Actually, you could have the word query at the front there, but it's optional. And then me, so that would be, so what's inside the brackets is what's known as the root query. So me is a field on root query, and then name and occupation are called a selection set, and those are fields on me. As you go down the hierarchy, everything is essentially a field. And so when you run that query, you get back something like this, which pretty much the part on the left looks pretty much like the one on the right, with the exception of data. That's part of the GraphQL spec, so every query result is going to be under a root node of data. And so the part on the right you should recognize is just plain old JSON. So the next important part is mutations. And a mutation is, as you would think, it's a way to change data on the server. So here's an example of a mutation. And again, this is, we start with what's called the root mutation. And then change job is a field on root mutation that has arguments of ID and new job. And user part to the left is just simply an alias, so that we get back data get back a bit of data that looks more like what it is that we're getting back. And so what this does is it changes the job of the user with ID 123 to lion tamer, and then returns the ID and occupation. So we would be getting back something that looks like this. Now, you might be wondering, if you're building a GraphQL client and you're writing queries and mutations like the bit at the top here, that's essentially just a string that you're sending up to your server. But as you see, it has some dynamic elements, that being the values 1, 2, 3, and lion tamer. And so you might be wondering, well, am I going to have to be doing some kind of string concatenation or string manipulation on my client? Well, no, you wouldn't want to do that. So the next thing to look at is variables. So this mutation is actually identical to the one we just looked at before in terms of how it functions. The difference is that we've added what's called an operation at the top level. Change user job is an operation that defines the fields that the operation needs. And that being ID of type ID, a new job of type string, and both are required. And then we happen to be passing that into this top level field. So what we'll be doing is sending to the server this bit on the top and this bit on the bottom together in one request, and then the server is going to take the data that we've provided and do its work with that. So what? What's so great about GraphQL? This kind of is going to go back to the REST pains a little bit. You can almost always get all the data that you need for one view in a single call to the server. It's a little bit more intuitive for front-end development. As I mentioned, the query shape and the result shape are pretty much always parallel. So there's a less of a cognitive load than on front-end developers to build queries and understand what they're going to be getting back. It's self-documenting, so there's no swagger or any of that stuff. Because we're creating a declarative schema, we can interrogate it and get full information about everything that's supported on the API. You'll see this in a minute that there's a special query that all GraphQL servers have to implement via the spec, and it's called introspection query, sorry. And it basically returns everything there is to know about the server. And there's very little that the coder has to do other than maybe putting in a few comments or a few descriptions to feed that documentation. So having that kind of immediate, always available, complete documentation for an API server opens up some pretty cool use cases, such as potential code gen, code validation, auto-completion, all kinds of stuff like that. Potentially some very cool IDE support. You'll see a little bit of this. I'm going to show you a tool that makes use of this metadata from introspection. GraphQL helps with performance optimization, and if we get to it, I'll show you a little bit about what I mean there. The biggest thing, I think, is that access patterns and features in applications or clients just change a lot faster than the structure of the data on the back end of the servers. So really, the back end process and the front end process can move forward really much more independently of one another. And that can be a big help. This slide is actually a little bit old. I think I took this from a presentation I gave a few months ago, but it's mature. Facebook, certainly this 300 billion requests per day is probably almost all Facebook. But they've been using it for a long time, and it's pretty mature. GitHub, back last fall, announced they were building a GraphQL API for all of their functionality, and I'm not sure the exact status, but I think it's up and running now. And that's going to probably stimulate adoption by the tech community, since everyone uses GitHub. There's server support already for most languages. A lot of clients support graphical, as it's pronounced there, which you'll see in a minute, is a pretty cool, pretty simple but very, very powerful. It's kind of like Postman for GraphQL. Apollo is a client library. They have some server stuff, but it's primarily a client library for React, Angular, and I think just vanilla JS that makes the coding on the client side a lot easier if you're using one of those frameworks. I use Apollo in my stuff. There's even some platform as a service providers springing up. So these are, think of like Parse or Firebase. So this is going to be really nice for like mobile developers who don't want to worry about building a server. Okay, so let's get to building. As I said, there's a lot to cover, so I'm probably going to do mostly copying and pasting from my reference app, which I also have up here. So what we're starting with, I should say, is a Rails 5.1 API app with which I've already built a domain. So all the active record models and stuff are already built, and I chose Star Wars, little subsection of the Star Wars data. So looking at this model kind of gives you the whole picture. We have a film that has and belongs to many characters. We're not actually going to really deal with planets. And then it has many reviews. The only other thing to know about this domain model is character is actually, I'm using single table inheritance, so there's two kinds of characters. One is a droid, and the other is a being. And droid, I think, has one property, primary function, I believe, and then being has gender. And these are the actual only three genders in the Star Wars universe, by the way. It's in the data. Okay, so hang on, I've got a little cheat sheet here on my next slide as to what I'm going to do first. I don't think we're going to get through maybe but about half of this, but I'll try to hit the most important points. So let's start with just building a Hello World server. So the first thing we're going to want to do is use the, go and get the GraphQL gem. I think it's called GraphQL Ruby, but this is how we get it, so we'll just... Okay, so the first thing we want to create is a schema. And we're going to do that under GraphQL. I'm going to cheat and copy and paste so as to save time. Our schema. Okay. So GraphQL schema equals GraphQL schema define, and then we've just got essentially some macro methods here to define our schema. And so we're saying every schema can have, the top level of every schema is a query, a root query, and a root mutation. So this will be our root query. And so this types query doesn't exist yet, so let's create that. Okay, so let's have a quick breakdown of this. Pretty much everything, well, not everything, but the main things are just types. And this is how we create a type, object type.define. Give it a name. This is how our client will know the name of this type. And then we have our one field, which is hello. It is going to return a type of string. And then we need to tell our server how to resolve that when it gets to hitting this field. So this is the signature. I've got those underscores just so my linter doesn't complain, but because these are unused. I'll go into a little bit more about, but this is the signature of a resolve method. Of every resolve method in GraphQL is going to be object, which is the parent object, and then I'll go into the rest of that later. But we don't need any of that to just do hello world. So we are almost done. The last thing I think, I've got a couple things to do, but I'll create GraphQL controller.rb and copy it. Before we look at that, let me just do our route. Okay, so there only really needs to be one route. The route is GraphQL, and we're going to have an execute method on our controller, and then we're going to accept a few different verbs. Standard routing stuff. So let's just take a look at this controller execute action real fast. What we're going to expect to come into us here are a few params, one called query, which is simply a string, which is one of the queries that we just looked at. Variables, we talked about variables, so this will be deserialized into JSON, or, well, really into a Ruby object. It's a Ruby hash, I guess, but it'll be coming from JSON. Context, so this is just blank here. We looked at the signature for resolve method, and we have the context everywhere available, so that is automatically populated with a bunch of metadata, such as the AST of the query and some other sort of GraphQL gunk. But we can pass anything that we want in here, so I'm not going to show this example, but we might pass in here, for example, current user, so as to do authorization anywhere inside of our GraphQL schema. And then this operation name, by the way, the one thing I didn't mention about the operations is the name is completely optional. It's just really useful for maybe like debugging, so as to not have it be anonymous. So pretty simple. We pass in the query and this other stuff, get back a result, and then render it as JSON. And that's pretty much our functioning controller. So this should do the job that we want it to for hello world. Let's see. Oh, I have to start the server. So our server's running. So this is the tool I mentioned that's sort of like Postman for GraphQL. It's called Graphical. It's also a Facebook creation. It's really straightforward. We've got, we type our query here. We can put our variables down here, and then the results come up here. It has auto-completion, so
Anybody can increase the size of that?
I think I can, yeah.
All right.
Yeah, I think whenever I refresh, it's going to shrink again. But yeah, so hello. Let's see if it works. Yay! Hello world. So this is really cool. This is the docs. Oh, I should just point out here. This bunch of gunk here is the introspection query I mentioned. So as soon as we refresh this graphical tool does introspection on my server, and then it gives me auto-completion. You know, it tells me, gives me a little red squiggly there when it's not a thing. And it gives me full navigation of everything that I have, that the server supports. It's pretty cool. All right, what's next? Okay, so now we're going to do get out of hello world and do an actual query. Let's call this films. All right, let's just cheat again here. Okay, so we're putting a field called films on our root query, saying that it returns a list. This is the kind of a little weird notation for denoting a list of films. Now, this is in a lambda. That's really just to avoid any kind of file loading issues. It's just lazily resolving the type so that we don't have any issues there. And then the resolve is just doing basically films.all. So this will not work quite yet because we do not have a film type. So let's fix that. And just go grab it from here. Okay, so again, object type, we've seen that before. Name is a film. Here's sort of the most you have to do to do documentation. Oh, there is another one. When you deprecate a field, you can put a deprecation notice on it. That's kind of how versioning works, GraphQL. And then we have a few, looks like all the fields here are required, non-nullable because of the bang here at the beginning. When this bit of code runs here, the resolver, our GraphQL gem is pretty clever about just essentially taking our GraphQL model and mapping it property for property into the GraphQL type. But in this case, because we prefer to use the JavaScript idiom of camel case in JavaScript land and snake case in Ruby land, we have to tell it. The gem isn't going to know what release date camel case is on our active record model, so we just give it this to. And there's middleware and things where you can sort of make it automatically do all this, but this is the kind of the basic way to do it. So let's see if we can run a query on films. Sometimes it's kind of slow to catch up. Again, just to show you a little bit about how the documentation populates. So we can totally navigate all through our documentation if we want to. So hello is no longer there. Films. All right, there's our films. Okay, so now we have a GraphQL server with a real query on our domain model that returns films. Okay, now, as I mentioned, a character, there's two types of characters. There's droids and beings. And so GraphQL has to have a way to handle that kind of polymorphic situation. So it uses something called interfaces and unions. So let's go ahead and build that out. I'm just going to add a few files here real quick. Character interface. I'll fill these in a second. Character union. So we'll start with our character interface. So an interface is, it's kind of what you think of it. It's almost more like a mix-in. So this looks pretty much just like a regular type. It has a name, it has a description, it has a set of fields. But by defining it as an interface type, it allows us to reuse it in kind of a cool way. So let's take create our being type. So by putting an object can implement multiple interfaces, so that's why it's an array here. So this essentially means that the being is not only gender, but all the other fields on the interface. And likewise, let's go and get the droid and see that that's same deal. So it has primary function as a field that is not part of the character interface. So it seems like we ought to be done, but not quite. And the reason is because when we want to add this list of characters to our film, so now we want to add a field called characters that is an array of, oh, it's not character interface because it needs to not be the interface, it needs to be the actual things, right? So that's why we create a union type that will allow us to define that as our return type for the list of characters. And so the character union, basically we're just saying, here are the possible types that could be in that list. Okay, you think we're done, but we're still not quite done. And the reason is that when the schema tries to resolve the field of characters, and it gets a collection of active record models that are a mix between droids and beings, it doesn't know how to map which thing to map that to, which GraphQL type to map that to. So we need to add another little bit of code to our schema, and that is essentially a little lambda that's going to resolve types. And this is, sort of one method for all types in your whole world here. So looking at this code real quick, again, we're back at our top level schema, and this is has actually not the exact same as a resolve, but similar signature. So all we're doing here is saying, if the type you're trying to resolve is a character, then let's get the exact concrete type name of it, which is going to be droid or being, constantize it, and append the module here. And so that's how we're essentially, we could probably maybe find a more conventional way to do this for all types, but this works. So let's see if it does work. Reinterrogate. There we go. So now we have characters. So one thing I'll point out here that's an important kind of way to think about GraphQL is, you'll notice I've said, I want my list of characters. Well, you might think, well, okay, just give me my list of characters. What else, what do you want from me? Can I just get characters with everything? No. Every field is resolved potentially independently in GraphQL, and so you have to say what you want down to the leaf node, which is always a scalar type. So you can't just say, give me a complex type or a list of these complex types. So, something else here. We don't have any fields on character. Well, that's because of the way we did it with this union business. So now we have to use something called a fragment. So I want the fields on character interface, which has all those fields that we just looked at. So the name and the, what else? Eye color, let's say. And then if I want the fields on being, I create another bit here. So now I get gender. And on droid, I primary function. Notice that the droid and being have all the fields, but I don't want to enter them twice, once for each, so I can just do it on character interface, and then I get everything back. So now we're getting for characters name, eye color, gender, name, eye color, primary function, etc. You can also always, by the way, and libraries like Apollo do this, you can always get the type name. So here we have type name being, type name droid, etc. So if you need to have logic in your code to handle these differently when they come back, that's built in. I think I'm running close to where I want to take some questions. There's a lot I didn't cover. Yeah, I didn't even get to mutations. Yeah, let me stop there and ask if there's questions. Yeah. Questions? Yes.
So what's the persistent data that you are using for the GraphQL? The persistent database?
Right, so GraphQL is completely agnostic to persistence. It knows nothing about it. It's strictly an API system. This happens to be PostgreSQL, I think. Active record PostgreSQL.
So when you write your GraphQL, it does multiple queries to fetch all the data, or how does the query optimize?
So that's a great question. And that's down here about way farther than I didn't get to. That's batching. So one of the issues that you run into with GraphQL right away is it resolves it does essentially a visitor pattern walk down your tree of your query, and it resolves each field independently. And that's how it can return just what you asked for. So yes, that is going to, in fact, we can probably see it right here. Yeah. N+1. So you don't want that.
Can you make that bigger?
Pardon?
Can you make that terminal bigger?
Oh, sure. So you can see that for each film we're getting the characters independently, and we don't want that. So actually I can show you real quick in my reference project how that's handled. There's a great gem called GraphQL Batch that is a very flexible batching tool, and then a guy's created one on top of that called GraphQL Preload. So if I were using that, my code would look like this, where preload, think about what's after that preload is basically the same thing that you would put into a joins or includes an active record call, and it will do a pre-fetch. It actually, it does it lazily, so essentially for all the films you would have one query with all the IDs, like you would expect, nice, optimized. So there's ways to deal with that. More questions?
What about the NoSQL databases? How does this GraphQL work for NoSQL databases like CouchDB or MongoDB?
So GraphQL is persistence agnostic. It doesn't really have anything to do with that. So in dealing with this kind of thing like N+1 issues, I'm not sure, but I presume there's some way to handle that. Yes?
So if either you've already got an API or you're thinking about making an API, what in your opinion would be a good indicator to be like, oh, I should probably use GraphQL versus just I'm gonna call some two JSONs on some objects and maybe just the regular REST interface.
Frankly, after building a couple of apps with GraphQL, I can't see a reason to do REST in a greenfield situation versus GraphQL. I just think it's a real nice way to build apps and very flexible and for all the reasons on one of my slides there, I think it's a great way to build apps. I wouldn't necessarily tear up a RESTful API that's working unless you're hitting some of those pains. Now, there are cases, for instance, I think someone at Facebook did an entire sort of shim over top there's I guess a page out there, Swappy, Star Wars API, which is where I got this from. It's basically an example REST API site, and the GraphQL team created a Star Wars API in GraphQL, and they do nothing but call the other. So it's a layer on top of it. Now that seems kind of like excessive too. Maybe that's more just for demonstration, but yeah.
What's it like to consume an API, a GraphQL API, in something like Zapier?
I'm not familiar with Zapier. What's that?
It's kind of like a middle layer API consumer. You can create connections between apps.
It's kind of like this and that.
Yeah, it's for automating apps together, Trello or something else.
You consume an API A and you feed it into API B, and it makes two apps talk to each other.
It's just JSON though, right? Like the return of the GraphQL API is JSON?
Nope.
It's not?
Nope.
Word.
I tried to write a GraphQL parser for some of the stuff I was doing. Sorry to interject, but it drove me nuts trying to get, because there's no, I was looking for something similar to the JSON parser because I was trying to use it for testing, and I found it a nightmare.
And you're parsing GraphQL queries, not the results.
Ins and outsies, both of them.
Okay. I mean, really, the result is indistinguishable from what you would get from a REST API. It's just JSON, right?
But you're calling you just have the one endpoint, right? So you have to format your request based on what you're requesting and send it to that one endpoint.
Yes. So basically, what a GraphQL request looks like is probably most of the time a post. You can do a GET. Depends how you set up your server, but a post, and the payload is going to be a JSON payload with three things in it: query, variables, and operation name. And that's it. So the query part, and that's query means query or mutation, will be a string, and it's simply a composed GraphQL query. Excuse me, and then the variables, as I showed how you would pass in variables, that's what that's for. And then you get back, and it's simply a accept type JSON, content type JSON, and then you throw in an authorization header. You need that.
So you didn't have any issues having to know the ontology of, like, because you have to know essentially here is all of the things nested, because it used to be, because it's all one endpoint. From a testing standpoint, how I would approach things is I have a blob of data for something. I'm going to fill out a form, and I'm going to make a call to that REST endpoint. I'm going to compare the data I put into the form to the data I'm getting back from the API. And when you have to do GraphQL, you now have to figure out what the nesting of the data that you need throughout the entire to get, because you have to fill out everything. And it could be that the company I was working with just implemented GraphQL really poorly. That's entirely possible. They didn't know what they were doing. I know that. But
yeah, I guess.
But at the same time, like REST gives you a really, this chunk represents what this data is. Where in GraphQL, you have access to everything that you have to know ahead of time what you're looking for.
Right,
before you get it.
You should know that, right?
It makes it harder to create a
It's
general.
kind of like saying how to
general
test
parser.
a SQL query.
Well, what I'm
You can't
saying
test every
is,
possible SQL query.
well, but that's the problem though, right? Is now you have to hard code every single approach to testing. Anytime anything changes, you have to change what you've hard coded instead of just being able to pass in.
Let's talk after. I don't quite understand the testing scenario. I just haven't encountered that. But yeah, let's talk later.
It drove me nuts as always.
How do you typically test in an app like this?
So another thing that I didn't show you is those resolvers that were in line in the types and what have you. There's ways to pull that out into more testable units. Like there's something called a function that where you can pass in perhaps one of the things that one of my resolvers has to go and ask the post office for information, and so I pass in my post office service into that as a dependency that gets injected, which I can mock at test time. So all of the resolution code really should be pulled out of the types and schemas that I showed you there for testability purposes. And then everything else would be really sort of functional or end-to-end tests. There's not a good way now to do unit tests on the schema itself. That's something that might be useful in the future. You know, my coverage isn't so far that I'm at that point yet. But I do write functional tests, which test essentially end to end.
You mentioned that mutations, you don't need to have a name for it.
Correct.
So I understand, so I assumed that the name, when I saw the name, I was like, okay, that corresponds to some kind of command handler on your server side, so you know what to do.
Let me go back there real fast.
You know what to do.
Okay, one more. Here we go. So change job, the field, it has to have that name. So I'm going to have a field on my root level mutation called change job, and it's going to have two arguments, ID and new job. But this signature up top, which that explains why I don't even need an operation at all, right? I can just hard code my data in here. The operation is just a way to define the API into which I'm passing my variables.
But you still need that change job.
You need change job, right? So this could be mutation, open paren, without the change user job. That's really just informational.
Okay.
And the other thing I'll point out is, so using variables, this example is with a mutation, but you do that a lot with queries as well. So when you're doing this with a query, this top level signature, this operation definition, you're not necessarily passing all the variables from it into this first field here. So imagine an operation where you're querying a list of companies, and then you have a subselect of employees. So you may want to say, okay, give me companies that meet this criteria, and then I just want the employees that meet this criteria, or some kind of pagination or whatever. So you define all of the variables of your operation at the top level, and then you sprinkle. Does that make sense?
Yep.
All right, well, thank y'all.
All right, so we're going to go ahead and take a break. Before the break, though, I do want to let our sponsor say a few words. So, ladies would like to go first? Of course. We have InterSys sponsoring the beer again, so thanks again.
We'll keep this pretty short and sweet, guys. I hope y'all are enjoying the beverages. My name is Priscilla. I'm part of the TA team out at InterSys Consulting. InterSys Consulting, we are a big data application development firm headquartered here in Austin, Texas. We've been local for about 20 years or so, with offices also in Phoenix, Arizona, and New York City. So we are coast to coast with our offerings, and most excitingly, we just opened a location down in Guadalajara, Mexico. So we are also offering some consulting services internationally. Our primary line of business is going to be offering our staffing services, but from time to time, our existing clients do leverage our TA team to help them fill some contract to hire, and everyone's favorite direct hire positions. And this is Crystal. She'll go ahead and tell you a little bit about our clients.
Hey guys, please drink all the beer so I don't have to lug that back to my car after this. So we've got a couple of really exciting projects going on, so I'm just going to kind of give you a high-level overview of some of the things that we've currently got going on. We're looking for great talent. So if you hear something that kind of sparks your interest, come see me after the chat. I'll give you my card, and we can connect. So the first project we have is we're actually putting together a Ruby feature team for a e-commerce company here in Austin, which is to tackle a couple of project initiatives that they have. So Ruby feature team looking for about 4 people. So that's the first one, and I can go into more detail about that if you have any interest, you know, the full tech stack later. The second one is going to be a large car manufacturer here in the Austin area. They are putting together a brand new end-to-end e-commerce platform that will essentially allow their consumers to purchase their cars 100% online without ever having to go through the painfulness on Saturday at a dealership. So we're actually in the process of, I think we've hired about 30 people into that team.
30 people in 30 days.
We've got, 30 people in 30 days. We actually did that. That was pretty amazing. We've got about 7 open positions right now, but probably about another 20 to 25 to go total. And that's anything from application development, UI, QA, SDET, you know, kind of all over the place. So just to kind of give you a broad idea of that. What was the third one I was going to tell you?
I'm not quite sure. But however, InterSys does offer a $1,000 referral bonus. So if you yourself are not in the job market and maybe a friend or a colleague is, definitely send them our way. Or even if you have that pesky coworker who is always eating your lunch and you want to send them our way, we will pay you $1,000 to take them off your hands. So,
you know, come see us. I've got my cards if you're interested at all in chatting. You know, I'd be happy to connect with you guys. Yeah, drink up. Thanks.
So during the break, please feel free to mingle. Come talk to the lovely ladies from IntraSys. Also, come say hi to Sept from Austin Frazier. And bathrooms, for anybody that needs bathrooms, they are all the way outside by the elevators. And we will be probably like maybe 10 Yeah, we need to do like one more beer maybe. So one more time, I'd like to thank Sept from Austin Fraser for maybe sponsoring our pizza all year, which we really appreciate.
Thank you guys. I am Zachary from Austin Fraser. I focus specifically on Ruby recruitment here in Austin as the open source team lead. Now, there's a lot of recruiters here tonight and don't want to talk your ears off. I was talking to the Prey guys about crypto and algo stuff. I've got a couple of clients here in Austin always looking for Ruby, kind of well-rounded software engineers who are interested in or have some experience in crypto or algo. So if anybody's interested, I'm doing some really cool work with a really cool client doing offshore oil rig communication type stuff, which I'm loving. I think it's really awesome. I would love to get some top talent over. I've got clients specifically hiring right now, all in Austin. It's my only focus in the e-commerce space. Multiple SaaS clients. A healthcare client is currently looking for Ruby guys. Always kind of at that lead level, happy to talk to, or not lead, I should say senior level. Always happy to talk to junior and mid-level talent. Any career advice or resume advice I could give, don't hesitate to reach out. I'm Zachary, my last name is Tickle. I'm easy to find, just like Coochie Coochie Coo. Don't hesitate. Thank you everybody, y'all enjoy it.
Thank you, Zach.
Hey everybody, thanks for coming. It's good to see such old friends and new friends. Can everybody see this okay in the back? Just check. It's literally an H1. I have no more H's. I can't H it anymore. So this is Chloe. I'm Mondo, and we're going to be talking about Kubernetes. So how many here have heard of Kubernetes before? Besides like the abstracts. How many of you have used it before? How many of you used it in like anger? Super cool. So the reason we're here, right, is because we think that Kubernetes is kind of the way that we're going to be deploying and managing our applications and services in the future, right? Either Kubernetes or something like it, right? We're not going to be doing Capuchon deploys anymore. We're not going to be using Fabric. We're not going to be doing any of that stuff. We're not going to be dealing with Capuchon 3 versus Capuchon 2 or weird Ruby gem versions installed. None of that nonsense. Just Kubernetes, right? We're not going to get too super far into the weeds, right, on like how Kubernetes is built or how it's run. This is definitely more of like a user-centric introduction to Kubernetes, not how you run it or how you operate it, right? That's a much deeper, longer talk, and Ceci said we only have like 25 minutes, so blame Ceci. So what exactly is Kubernetes, right? So Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. Okay, cool. So yeah, when I read that the first time too, and like the 17th time, that's how I felt. But it's okay, Dean. Okay, yeah. super dreamy. So we know all these words, right? We know what automating is, we know what deployment is, we know what scaling is, we know what management is. Containerized applications is really the only thing that I wasn't super strong on before I started into my Kubernetes forte. That's where we're going to start, right? Because that's actually kind of the key that unlocks all of the cool shit in Kubernetes. That's what lets Kubernetes be Kubernetes and do all the things that it does. So we're going to start with a containerized application, kind of work our way towards Kubernetes. So for us, our containerized application is going to be a very simple Rails API running inside of a Docker container. So how many folks here have run Rails or something else inside of Docker before? Super, most folks. So for those who haven't, if you have any questions, you can ask Chloe. She'll super answer them really great.
Sweet bust.
Yeah, so we'll go through, these are our quick steps, right? It sounds like most folks here are kind of familiar with Docker and familiar with running Rails inside of it, so we'll go through it kind of quick, leave more time for Chloe's demo at the end. We're going to build an app, we're going to containerize it, then we're going to test it, we'll quick sanity check it, then we're going to share it, and then get Kubernetes to run it. So we all know this, right? Just creating a basic Rails scaffolded application, just kind of the API side. We can't really talk about containerization without talking about Docker, right? Docker is the software that we're going to be using to build our containers and to run our containers, right? And sometimes when folks talk about Docker, they get kind of lost in the weeds a little bit. We're going to try to not do that. And the reason that it's easy to get lost in Docker is because it's kind of a lot of things, right? It's a runtime, right? You can see some of the processes that are running here when I do a PS script for Docker. But it's also a container format, right? And it's also a spec for those containers, right? And all kind of wrapped up and rolled into one. So at the end of the day, it's not magic, right? It's a bunch of processes that are running on your machine or on your production machines, right? It's all open source, and you can go into the code, and it's super cool. So it's nothing super big. Docker containers, right, are where it's at, right? And a container is nothing more and nothing less than a lightweight, standalone package for your application, right? And sometimes when people start talking about Docker and Docker containers, they talk about the shared kernel and overlay file systems and all that stuff is super great. But the main key takeaway that I want everyone to come away with regarding Docker containers is that you can just think of it as an artifact, like a binary, right? Like a program that you can run that is your application running inside of it. It's got your application, and more importantly, it has all of its dependencies, right? All of its configs, everything kind of all rolled up into one. And because of that, anyone that runs Docker can run that one container, right? I have my container, give it to Chloe, she runs it on her laptop. I give it to you guys, you can run it on your machines, and more importantly, Kubernetes can run it on production, right? Because it's a thing that it runs. So how do we get there, right? You start with a Docker file, and this is just the definition, right? This is what you use to define. Everyone got to the part. That's great. It's how you define how you want. It's the instructions you give to Docker to how to build this container. Right? It's kind of like a makefile, right? It's a series of instructions that Docker knows how to run or execute to make your container, right? So we're building it from the Ruby 2 base image, which is an Ubuntu based image. We can do that update and all this stuff. We can create an app directory, copy our gem file and gem lock file, or gem file lock file in there, run gem install bundler, bundle install, get all of our dependencies into the container, copy kind of the meat of our application into app, open up port 3000, we're just going to run it on 3000 just because. And then the last thing that's going to happen in our Docker container once it's built is we're going to run this command, which we all know is on the entrepreneurial server. Okay. So once we have the Docker file, we do, I need more beer. We do Docker build, right? And we give it a tag, which is this long, stupid name, and tell it to look in the current directory for a Docker file. And this is kind of the snipped output. You can see it kind of going through all of the steps while it's building up our container. And at the end, we get successfully built 4A3VC, right? And that's our artifact, right? That's our thing, that's our image, that's our container. I wish I could show you like where it lives. Docker doesn't make it super easy to see the one thing. It's not like a singular file or a singular directory, right? But Docker does know where it lives. That's good enough for me. You can do a Docker images, and sure enough, you see it, right? There it is in all of its 4A3VC news. So now we've got our container, right? We want to run it just to kind of check and make sure that it's legit and does what it's supposed to do, right? So we call Docker run. Tell Docker run to run it so we're going to be running on port 3000. We want to open up port 3000 on the host that's running Docker, and then we give it the name, right? Run this thing. And we see what we'd expect, right? Booting Puma, Rails 513, and all the normal stuff that you would expect to see when you do a bundle exec Rails server. And sure enough, if in another window, you type Docker PS, that's what's happening. You got your image, there's a container, and it's got the ports opened up. So far so good. We do a little sanity check, curl localhost 3000, which still I think is a great band name that no one has ever used. And we get our Rails application, right? So We have our container, seems to be running, seems to be solid. Now we want to share it to the world, or at least to Kubernetes, right? So we do Docker push. And Docker push will send it up to a registry, container registry, right? Which, if you're not familiar with, is kind of like GitHub, but just hosts these artifacts, these things, right? We're going to be doing our demo in Google Container Engine. So we're using GCR.io, which is Google's container registry. That's why we have that G cloud in front of it, right? But if you were doing this yourself, you just did a Docker push, it would by default push to Docker Hub, ask you for like your credentials, create a free account, you can kind of push it up there. So here we are. We have our container, right? We have it publicly available, hopefully, somewhere in Google's container registry. And we now want to run it in production, right? Before we go to Kubernetes, show how that's done there, Chloe and I have come up with some vignettes to describe how this used to work versus how this is really all Chloe's idea. None of this was mine. 100% Chloe.
I'm also the drunk one.
Okay, hold on. Hello, I'm 90s sysadmin Mondo. I'm super into DMX and running Linux on the desktop.
I'm 9 years old.
Read the line.
Hi, this is 90s Chloe, and I'm 9 years old.
That's weird.
And I need you to run this Perl web.
That's also kind of weird, but that's okay. So, 90s sysadmin Mondo, sure thing, no problem. So, I mean, it'll take a little bit of time, right? So I have to call HP. HP's got to ship me a machine. Then I've got to take it to my data center, and then I've got to rack it. Then I've got to install an operating system on it. Then I've got to install some users on it. Then I've got to install Perl. Then I've got to install the Perl models. Then I've got to install Apache. But it's not that big of a deal. Because I've got like 15 shell scripts that do it all for me, then they never work. So, it's going to take a couple of weeks, tops.
Cool.
And see. Yeah. So, fast forward 10 years. Hello. I'm 2000 sysadmin Mondo. I'm super into Rihanna and T-Pain. And this year is definitely the year of Linux and desktop.
I'm 2000's Chloe. I'm 19, and I need you to run this J2 application.
You're super good at programming to get to this point. So there's no problem. It's not like it was in the past. I've got this new beta thing called Chef. And I've been using this super new cool thing called AWS. So all I have to do is write a little cookbook and get your thing going. Wait, say Java? Okay. So we can't use Ubuntu with Java because Oracle has a user license agreement that we can't automatically. So can we use like OpenJDK or something like that? Okay, so I'm going to have to do a little bit of research on how to do this, but it'll be okay. We'll get it done in a couple of days, no problem.
Sure.
And see. So we go from a couple of weeks to a couple of days, right? No big deal. Now, what's today look like?
I'm Wonder Woman.
Yeah, she's. I don't know if you just get just like that.
Hell yeah.
Okay, fine. So I'm 2017 Mondo, and I just like can't fucking even anymore. I just can't. I mean, I haven't checked Twitter in like 20 minutes. I don't know if like people are all dead. I don't know what's going on, but like I can't fucking even, let alone like Linux on the desktop or deploying shit. Like I just fucking can't anymore.
I'm 2017 Chloe, and I also can't fucking.
No one can.
But I made a Rails app. Will you run it?
I will super kill. So does it run in a Docker container?
Yep.
Sweet. So we can run kubectl run, kubectl expose, and done and done.
Sweet.
Now it's what we try.
Okay.
And see.
You already
So how does that work, right? How did we get from a couple of weeks to a couple of months, or a couple of weeks to a couple of days to a couple of minutes, right? In this case, Kubernetes gives us that. Right. This is what a Kubernetes cluster looks like. Right. It's a very basic, kind of minimal version, but you have a master and a couple nodes. Forgive my awful diagram, but all these are just Linux machines, right? They're just, AWS instances or whatever. They're just Linux machines. You can SSH to them. Nothing magic about them. The only thing that defines their roles and what they are is kind of what pieces of the Kubernetes code base they're running, right? The master is running certain parts like the API master and the controller manager and the scheduler. The nodes are what are actually going to execute these little pods, which are kind of wrappers or holders for our containers, right? The master is what we as users will be talking to most, and we will be talking to the master via kubectl and kubectl command, and it's super kind of nice. It just talks over HTTPS, right? And we can actually inspect the traffic. This is our kind of slimmed down version of our Kubernetes config file, right? And you can see up here that we have this server definition, right? And it's just HTTPS 35.188, et cetera, et cetera. It's just a machine. It's just a machine, that's all. So if we were to run kubectl get nodes, which will show us, right, shows kind of the definition of these nodes down here, and we bump up the verbosity, we can see a couple of interesting things. You can see that it reads our config from where we show we expect it to. And then it gives this super nice curl output, showing that it straight up just talking to that server definition that we had, right, in our kube file. And you hit /API, view1 nodes, gets a bunch of JSON down here, then kubectl massages it and shows us that these are our node names, right, and their status, and what version of Kubernetes that they're running. Super basic, super easy. These nodes are, so the masters are running like API server and all that stuff. The nodes are running something called kubelet, just another process, right? And kubelet is what the masters talk to execute our containers and run them. Now it's time for a live demo. That's it. Any questions up until this point? We can dig a little bit deeper in the demo, but awesome, great. So, is that, nope, the other one. I'll let you drive, and I'll drink.
Okay, y'all see that working?
Bigger.
A little more?
Bigger? All right.
Make it small.
My kind of people. Good?
Yeah. Bigger, please.
That's it.
Good?
Yeah.
All right. Okay, so I'm super bad at typing, so I copied most of this, so I will try and do the same. The first thing you can see here is just what it looks like when we don't run anything. So we just have our base Kubernetes service running. We're going to start at from the point of we've got our Rails app, we pushed it to a built it Docker container, we push it up to the repository, and then we actually run it. Alright, so what this command is doing is it's telling Kubernetes that I want to run the image that we created on port 3000. And if we look at the state of things again, we'll now see a little bit more has happened. So we've created a deployment called Truth or Lie, and a deployment, how would you describe that?
So a deployment is really kind of the definition of how we want Kubernetes to run our application or our container at this point, right? One of the cool things about Kubernetes is that it's kind of declarative, right? You tell Kubernetes how you want things to be, and then it tries its best to make it happen, right? So we just said run, right? Run and throw up our hands. And Kubernetes was like, oh, well, we'll run one and see what happens. Because that's where we are.
So at this point, we're running the container, but we still can't talk to it externally. So what we need to do next is run a command that will expose the port for us. Just telling you that. And we have to set it to type load balancer so that we make it externally available. If we don't, it'll just talk to internal services only, right?
Right. So just like when we told Kubernetes to run our container, it created a deployment for us. When we tell Kubernetes to expose that deployment, it creates a service for us. And we can actually look, can you do a get deploy truth or lie?
Is this running processes locally, or is it running it?
So that's a good question. This is actually running inside of Google Container Engine, right? So once that service comes up and has a publicly available IP address, like everyone here can hit it if you're on Wi-Fi, right? It's going to take a while, like Chloe was saying, because when we told it to do -- type load balancer, GKE is actually spinning up a load balancer for us, right? So that can sometimes take a minute.
It's actually up now. So now we have an external API that we can use to actually call our Rails API.
Do you want to curl it real quick just so we can see it?
Yeah, let's see. Let's see if I can type.
None of us here are good at computering, so it's fine.
That's cool. Did that right?
Looks good.
Alright, so we get our basic Rails page, and then I happen to know that our API has an endpoint called truth. And there's our truth. There's our lie.
It's not wrong.
So, if you guys would like to participate, you're welcome to curl the heck out of those two things. So far what we've done, we've built our container, we've made it publicly available, and right now it's only running one replica, which you can see.
Yeah, so we should stop a minute, right? Like, we've deployed something to production. Yeah, just like that, right? Like, no Capitano, no cat file, no that shenanigans. Only my friends are clapping, but that's fine. Aaron didn't clap, that's okay. On the inside. That heart is super. So I mean, that's kind of cool, right? That's kind of cool. Like, we don't, the way, that's not how I'm used to doing stuff like this, right? Like, I would have to provision a machine somewhere. Even if it's AWS, right? Have to provision a machine and get the code on there somehow. Get checkout or something, right? And then get Rails running. And then get like Nginx load balancing in front of it. Right? Like all this stuff. We don't have to do any of that. It's kind of. I'm done. I'm super done.
So, knowing how everyone wants to know our truths and lies, we want to spin up some more because it handles a lot. So, this is the shorthand way. There's a couple ways you can edit this. But all I've done is said, instead of having just the one, I want to have 4 nodes running, which you can now see we have a whole bunch more.
And you can see, right, that Kubernetes, I should pull up here, Kubernetes tried to do like the smart thing, right? Like excuse me, Chloe. It tried to balance them as evenly as it could across the 3 nodes that we have, right? Since we asked for 4, we had to double up on PJF8, but it does that for resiliency, right? Sorry, my board. Because these nodes can go down, right? I mean, the stuff is running in GKE, but it could be running AWS, could be running wherever, right? These nodes can go down and will go down, but right, 3 out of 4 still running is better than none out of 4. So Kubernetes like just did that for you, and we didn't have to define that. We didn't have to tell it to like try and do the right thing. Just kind of did the right thing, which I thought was special. Thanks, Kubernetes.
Okay. So as those developers are want to do, we want to change some stuff. We needed some new truths. We needed some new lies. So we wrote our code, got our PRs approved, merged it. We built our new container, we pushed it, and now we need to actually have our truth or lie deployment running. So it's pretty easy. We just set the new image to what we've called V2. And if we
Right, so this is another example, right, of Kubernetes being declarative, right? We didn't tell Kubernetes to go and change those pods or do whatever. We just said, you have this deployment, I want you to now set the image for that deployment to this V2 version. And then Kubernetes kind of updated the world and did it all for us.
And you can see here that now we're running V2. And I caught it in a state of bringing up new nodes and pulling down the old ones. So we should see them all running now. And if we go back, if that's too far, our lies stay the same, but our truth should be different.
Still not wrong.
Also, as developers, what we do, we like to break shit from time to time.
I mean, we don't like to break things.
I mean, it happens.
They just do.
Because, you know, you're drunk and stuff.
Some kind of
So, what this is going to do is there's actually no V3 in existence, so it will tell us that things are wrong, but because it detected that stuff was not working, it didn't continue to try and force itself to finish the change, it just stopped. So we can see that 3 of the nodes are still running just fine, and if we were to continue to curl, everything should still be fine. So our end users have no idea that we really messed them up.
Yeah. So one of my favorite things about Kubernetes is whenever you do something terrible and Kubernetes doesn't know how to resolve that state of the world, right? It doesn't panic and like destroy everything, which is what I would do. It just it just like stops in its tracks. Like Kubernetes cannot find V3. It doesn't exist, right? So it tried a couple, couldn't make it, so it decided to not tear down the old installation, let it keep running, let customers keep accessing that. I mean, it's not great that we have those 2 pods kind of in that error state, but it's better than all of them being in the error state and our customers getting 500s or whatever, right? 503s.
So naturally, we'd want to roll this back. There are a couple ways to do this. The easiest way is just to roll back to the most recent version that you were deploying previously. You can also...
Yeah, so we could run that command again, right? That set image and just set it back to V2, and Kubernetes will be fine.
They also have revision histories. And then, so we're on 3 right now, and that's the broken one. If we wanted to find the one that had V2, well, we know that one's broken. If it's V2, we know that that's the one that had the most recent working version that we're at. So since it's the previous version, there's a nice message. And this will just roll it on back. And if we look at the state of things again, now we're all back to happy and running, and our thing's on V2. You can also specify the version ID if you want to roll back to something before the most recent, but just wanted to show that, and I think that is it for my demo. Do you want to do that?
I think we're done.
Okay, any questions, guys? Cool.
Set the size of it.
I'm sorry?
Does it scale up and down on load, or do you devote for?
That's a good question. So Kubernetes has a bunch of other primitives, right, that we haven't talked about here. And one of those primitives is HPA, right? And you can tell, you can assign an HPA.
What does HPA stand for?
I don't know what HPA stands for, Ben.
Horizontal Pod Autoscaler?
Thank you. Horizontal Pod Autoscaler.
So it's a softball.
You'd think it'd be a softball question. But yeah, so it's kind of like a autoscaler in AWS, right? And out of the box, HPA will scale up or down based on CPU usage or memory utilization, right? But you can also tell it to listen to like custom metrics that your application may provide, and it can scale up and down accordingly. So yeah, you could scale up like this. You could pre-scale it if you thought that something big was going to be coming in a couple hours, or you could just tie it to an HPA. I mean, it all depends on your workload, right? And like these pods came up super quick because it's just a real basic Rails app. Some pods can take a while to start up if they have a lot of things going on, right? But yeah, so yeah, it does have a concept of something like that.
Where do you find like different environments?
You mean environment?
I guess I'm thinking like you have different environment variables, right? You have things different between your development versus your production.
Yeah, so there's a couple different ways you can do that, right? When you define your deployment, you can kind of pass environment variables through there, and those environment variables will get passed to each pod as they spin up. Kubernetes also has a concept of something called a config map, which is just kind of what you think it is, right? It's usually like a YAML or JSON file of just configuration stuff. And then you can mount that config map as a volume inside of your container, and all those things can be either exported as environment variables, or you can read them directly, or you can like pre-populate them via something like console or something like that. So it's Google. So Kubernetes is from Google. We didn't talk about the history and stuff like that, but the more you use Kubernetes, the more you realize that like, they've spent a ton of engineering years like running stuff under load in this thing, right? And so things that you as an operator expect to be there just kind of almost always are, right? And if not, there's a pretty simple way to get to it. I mean, I wouldn't say I wanted to have my babies, but it's it is really nice. It's really nice, and there hasn't been much that we've hit running in production that we've been like, oh, I wish Kubernetes could do this, but it can't. So yes, Dave.
Yeah, how does it deal with long-lived TCP connections through Amazon load balancers?
It deals with it about as well as you'd expect, which is kind of okay, but not super great. It's one of those things.
The reason why I wasn't clapping
Man. All right, so I owe you.
Was out of Indy. We've been going the ECS route, and I do feel like we've been rolling our own. And question for the room or anyone that might know,
Matt's waiting.
We really hit a bunch of just like pain trying to initially like bootstrap Kubernetes inside an existing VPC at Amazon. Has anyone been through that pain? And
It fucking sucks. We're trying to move to like Terraform to do it, and SaltStack, and it sucks. It just sucks. And we evaluated whether we should just move to Google. Because like, so the people that run Kubernetes, the people at Kubernetes, like Kelsey Hightower, people like that, are like, if you don't have people whose job, if you don't have the resource to have people whose job is to run Kubernetes, don't run Kubernetes. And so we investigated what it would take to migrate off our like shitty AWS installation into like Google, and the difficulty of doing so because there are things that don't translate directly, and we can't hit our SLA with their beta version of Postgres at Google Cloud. So we can't move to Google Cloud yet, but we investigated very heavily. Like I strongly suggest if you're going to do Kubernetes and you are small, investigate Google Cloud first.
And that's exactly why we're running our demo in GKE.
Yeah, we definitely are doing it, and we have people you can talk to if you decide that you want to bite the bullet.
We're just streaming this together with ECS now.
Yeah. Give Kubernetes some. Here's our prediction: is that AWS reInvent in October or November, they're going to announce Kubernetes for cloud support. Almost like if they don't, AWS has to suck for another year. Kubernetes like flip stuff so upside down that you look stupid for not getting on board with them. Like from a provider perspective, not from an operator. Super great.
I don't know which way I want them to go. Like some cost fallacy, how much we paid on campus on the road.
Yeah. So Spreadfast had a bunch of stuff in ECS, and they spun up Kubernetes cluster before I got there in AWS. So most of that back row back there are folks that you can talk to if you want horror stories and kind of, you know, the way through. Mostly Matt's fine. Yeah. So we should talk real quick about like what Kubernetes sucks at and is not good at, right? One of the things it's not good at is running by itself. Like you kind of have to tend it, you kind of have to run it and operate it just like anything else, right? It's super nice that we don't have to do, you know, like spinning up new servers with Chef and stuff like that, but you still need something to spin up that master and those nodes, right? Like I just clicked a button in GKE, which is super nice, to get those three. But I mean, like, who knows how much that's costing me? I have no idea. We should really turn this off. You know, but at SprintFast, where I work, right, we manage stuff through CloudFormation, right, and we're experimenting with moving to Terraform, but that's still like, I mean, we're still working through it, right? Because you still have to manage those those instances, right? You still have to bring them up. You still have to be able to talk to each other. You still have to be on a network that can talk. Some things can talk to the outside world, some things can't talk to the outside world, right? So you don't lose that part of it, right? That part of the complexity is still there, right? Another thing that Kubernetes is super not great at yet is things that require state, right? Like Brandon was saying, you want to use someone else's Postgres, or you want to run Postgres, you want to run that probably outside of Kubernetes right now, right? Kubernetes has these concepts of stateful sets and persistent volumes and stuff like that, right? It's still kind of not super there yet, right? So that may be a deal breaker if you want to pull everything inside Kubernetes. There's ways to bridge that gap and like have Postgres running here and then have things talking to it through Kubernetes, but it's still a little fledgling, right?
So, I mean, a common example maybe here is like you got a database, so maybe that's not managed in Kubernetes, but as my new V3 of Tutorials, I've got a new database migration I have to run.
Mm-hmm.
How does that fit into your whole, like, okay, just deploy version 3?
So there's two ways to do it, or more than two ways to do it. But there's the wrong terrible way to do it, and there's the slightly less terrible way to do it, right? So the wrong way to do it is to tie that to every kind of release of your image, right? And you always run a database migration, right? So what you would do is, while this is running, as you deploy it, as your pod comes up, like your Rails pod comes up, the first thing that it does, like remember that command that I had in the Docker file, right? You could have something before that does, well, it's like Rails and migrate, right? That's terrible. You don't want to do that. Don't do that. The right thing to do, or the righter thing to do, is you have like a migrator image, right? So you have this version running. You're saying, I want to move to V4 or V3 in this case, right? But that requires a migration. So you you create another thing that we haven't talked about yet, which is a job type, right? These are pods and deployments and services. There's another thing called a job, and it just runs, and then if it's successful, it turns itself off, right? So that job runs the Rails DB migrate, and that requires your software developers to be a little forward thinking and understand that, like, if we're going to run a migration, that migration has to be backward compatible, right? So if you're adding a column or whatever, right, like the old version of your software has to be able to run on that new version of the database schema, right? Because that way you can run that migration whenever you want to and still be running on the V2 version of your application, and then roll out V3 once the migration has gone through and everything's fine. Do something like that.
Can I ask another audience poll?
Do it, my man.
You mentioned, like, is anyone running any type of data store, persistent data store inside of a container in production? Docker and Go.
Yes. How's that been done? So, our managed by capacity, it's worker helpers, so you have to be compliant with everything you provides that manage that somehow. It's super tough.
So it's like,
You can treat it like it's RDS.
Yeah, we run all of our stats collection for our Kubernetes cluster is run as a pod inside of Kubernetes with persistent volume. So, there's a number of things that you can use to collect stats for Kubernetes. We use Heapster and InfluxDB, and all of that is mounted as a 20 gigabyte EBS volume to one of our Kubernetes nodes. And it's fine. I mean,
we've only lost the data twice.
Right. But it's one of those things that, like, it's kind of okay to lose that data.
So the answer is it's okay to lose your data. It's super cool to run
You kind of need it because all of your HPAs, those horizontal pod autoscalers, which
Come on, Ben.
scale based on CPU, which scale based on CPU, use that data collected by Heapster. But if you're okay with losing your data, yeah, why not? Put it in Scoop. We're kind of looking at moving more and more stateful things into Kubernetes, such as console. But that's
it's about gaining comfort. You start with
yeah,
a web server.
that's really what it ends up being.
You add more because it's production workload for us.
Mm-hmm.
It's just nice and steady.
And the biggest difficulty has been some idiosyncrasies in the way that Kubernetes interfaces with AWS and how it melts volumes to nodes that are running and how it selects the volume that it's going to attach to a scheduled pod. One of the things that happens all the time, and luckily we run our whole Kubernetes cluster in one Amazon availability zone, but if you provision a volume, it only exists in one availability zone. So if your Kubernetes cluster is in multiple availability zones, then you're really limited on where you can attach that volume all of a sudden. And Kubernetes does not do a very good job of figuring that stuff out. So it may try to schedule a pod in another availability zone and then be unable to attach the volume to it. And things just fail for a long time until it eventually figures it out. So, and it seems to kind of eventually figure things out, but it's a big pain in the ass. So that kind of stuff makes it difficult, I would say, to deal with persistent data and Kubernetes.
Can I do an ask the audience?
It's y'all's talking. This is here.
Has anyone ever heard of Heroku? Okay, thank you.
So,
has anyone had to pay for their own Heroku bill when it's over $100,000 a month?
I get all my stuff for free.
Yeah, so, that's, it's a very, very, very good point, right? And Brandon mentioned this before. Thank you, James, for bringing it up, right? One of the things, one of my primary jobs at Spreadfast is helping keep this Kubernetes cluster up and running and working, right? And most of that back row kind of does the same thing, right? It's a lot of money to spend on just people running this thing, right? So, I mean, Spreadfast is huge, runs a lot of stuff. It's worthwhile for Spreadfast and the kind of workloads that Spreadfast has, right? If you're spending 20 grand a month, 30 grand a month in Heroku bills, right? That's, you're really not saving much by adding on all this complexity for Kubernetes that Heroku kind of hides for you. They deal with it, they manage it, right? And you can just go about living your damn life, pushing your shit out, right? But sometimes that doesn't fit the bill, right? Sometimes, you, for whatever reason, your workload doesn't quite make financial sense to run under Heroku, right? Kubernetes is way better than just about anything else that I know. But thanks for bringing that up.
I work there, by the way.
And they're a great company. They're a great company. I have a lot of friends who work there. Not a lot of friends. I have 2 friends who work there, but they're super nice people. To be fair, the 2 friends are most of my friends. So, also, like I said, we run all this stuff in Spreadfast, and if you are interested in playing with this kind of stuff, learning this kind of stuff, operating this kind of stuff, we're super hiring on a lot of fronts, not just the operations team, but also application developers. So talked to pretty much anyone back there who was complaining about stateful sets in Kubernetes, and they can point you in the right direction. Any other questions? Let's go get drunk.
Hey everybody, so that's it for tonight. Socialization practice is going to be at the Ginger Man. Does everybody know where the Ginger Man is? Yes? Alright, yes, follow. Raise your hand, whoever's volunteered to lead people. That was
Do you want some just pick up some stuff?
Hey, if there's leftover pizza, please take it. Like for real.
Either I'm doing that or I'm going home.
And
I don't know.
I've got it.
No, we,
I recognize that I haven't done a whole lot of
yeah, we were just
That's not true. I guess that's what you have to say. It really is. It really is learning how to write every process. We learn a fair amount of code in our server and stuff.
Well, at some point I'd love to hit the venture after so the guys maybe like free up, might have.
Well, yeah, we're pretty early stage. All the products in beta. We've pretty much developers in Russia. And we're just closing the first starts with our PC round. We're hoping to kind of expand our network and support space. We've gotten a long way on the other side of the world. The mobile app I'm working on, it's getting to a point where we suffice it to say where we're looking for some.
Okay, I'm not flush with cash just yet.